Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in our today's mathematics digital class. So children, in our class today we are going to talk about some new topic that has been introduced in this class itself. That is, so we are going to learn probability part 1. So, this is a new topic children which is introduced in your class 9. Now, by the end of this session you will learn equally likely outcomes, random experiment and outcomes, trials and events, and also you will be defining what a probability is. So, children, so first let us learn about equally likely outcomes children. So, children, you can notice a school is shown on your screen, isn't it children? Yes. Meet Ravi and Vijay, both are friends studying in the same class, and today they have completed their test in the school and they are planning to meet evening in one of their houses. Let us see children what these two have planned to do in the evening. So, evening they met at their house. So, here Vijay asked, will you get full marks in today's test? So, what actually Vijay is doing is asking Ravi whether he will get full marks in the test which is conducted in the school today. Ravi replies, most likely I will get, because I wrote all correct answers. Then Ajay asks, will you get full marks? Then what Vijay replies? Yes, he says, no chance. I did not answer one of the question. So, he is telling that he is not going to get full marks as he could not answer one question. Now, both of them want to watch cricket match now. So, they want to watch India versus Sri Lanka cricket match. Now, what is the question he is asking now? Who will win the toss? Then here he replies that both have equal chances to win the toss. So, children, you know, coin is tossed. So, he says that both the teams have equal chances to win. Children, let us consider the statements which already they were speaking. Most likely I will get full marks in the test. There is no chance for Vijay to get full marks, and both teams have equal chance to win the toss. So, these are some of the sentences which they were talking. Ravi and Vinay are actually making judgments about the chances of particular occurrence. That means, they are judging like they may get full marks or they may not get full marks, or both have the chance to win the toss, isn't it children? So, in many situations we make such statements and use our past experience and logic to take decisions, isn't it children? So, to judge something we generally go with our past experience and also the logic we use. So, let us see some examples children where we use our past experience and logic in taking some decisions. Let us see children. So, here meet Mary. She also studies in the same school and always she carries an umbrella with her, and she has been doing for many days. So, she has come to the school with an umbrella in her hand. So, she was coming daily. So, almost many days she was coming with an umbrella, but it was not raining. So, one day what Mary thought is she do not want to carry umbrella that day. As it was not raining previously, she thought of not carrying the umbrella, but suddenly on that day it started raining heavily. She got drenched. Then the decision that she was taken is not correct, isn't it children? So, the decisions may not always favor us. So, she has decided not to take umbrella with her, but what happened children? The decision was proved to be incorrect. So, the decisions may not always favor us children, you need to remember that. Then during summer, it will be very hot outside your home children, isn't it? So, even then Mary carries an umbrella. So, she has gone from her home to the school. Now, while returning from the school, again it started raining heavily. But children, what happened to Mary now? Yes, you are right, she is not drenched. But why? Because she is carrying an umbrella with her this time. So, in this case, the decision taken by her is absolutely worked for her, because it has rained. So, thus we take decision by guessing the future happening, that is, event occurs or not. So, children, our decision may favor us and sometimes may not favor us children. I think you have understood what actually I am trying to say children, isn't it? So, we try to measure the things which occur or may not occur in our daily life children, as we generally do in our day to day life in measuring the things. Okay, children. So, what actually it gives us is, it gives or it helps us in taking the exact decision. Okay, children. Now, let us see a small scenario children. So, let us relate some of the terms that we are going to learn in this session. So, first you can see here a tabular form with term, chance and examples are also given. So, if you notice the first one, that is certain, what actually it means? So, something that must occur, right? So, that is certain, certain means it is going to happen, right. So, for example, if we consider Gandhiji's birthday is on 2nd October. So, it is going to happen on 2nd October every year, isn't it children? So, it is a certain thing. Now, if we consider the next one, that is more likely, what do you mean by that? Occur with great chance. So, that means you have more chances of occurring that event. So, let us take an example, Ravi getting full marks. So, we have seen in the previous discussion children, right. Ravi said he will be getting full marks, but may not be certain, but he may get more likely, right. So, that is an example for more likely. Now, let us take equally likely children. Now, what do you mean by that? That means they have same chance of occurring. Like for example, if we consider both teams winning the toss. Now, if we toss a coin, team A or team B, both can win equally, right. That is meant by equally likely. So, less likely if we consider occur with less chance. That means raining in the summer. So, you might have seen, right children. So, it may occur, but chances are very less. Then impossible things. Now, what do you mean by that? Something that cannot happen. So, let us look at the example, Vijay getting full marks. So, already Vijay only told clearly that he is not going to get full marks because he left one question. That means some marks will be deducted from for not answering that question. That means this is not going to happen, right? He cannot get full marks. So, children, I hope you have understood what are the terms and with examples related to those terms. Got it children? So, next let us clearly understand about these likely, equally likely, less likely and more likely. So, equally likely is exactly, if I take a number line with 0 and 1, 0 is the minimum and the maximum value is 1, equally likely will be exactly at the center. So, you know what actually center is here, right? Halfway between 0 and 1. There we have equally likely, like, and we have less likely towards the left side, that is towards the 0, and more likely almost more than half and nearest to the 1. This is more likely. So, we have seen the example also children, right. Equally likely means like tossing a coin, and less likely means you can take an example of raining in the month of March, right. Summer you get less chances of raining, right. Now, whereas more likely cold waves in the month of December. So, generally we do get cold waves in the month of December itself. So, this is nothing but most likely thing that is going to happen, right children. So, next children, let us try these questions which are going to be displayed on your screen. So, classify the following statements into the categories like less likely, equally likely and more likely. So, the first question is rolling a dice and getting a number 1 on the top face. Yes, it is equally likely, children. Now, let us move on to the next question, that is India winning the next soccer football World Cup. So, this is less likely, children, because if you see the past thing also, like India has never been into the soccer cup, right. So, chances are very less. Then if you consider the third question, selecting a blue ball from a bag of 5 blue balls and 2 black balls. Yes, children, it is more likely, because there are more blue balls than the black balls. So, the chance of selecting the blue ball will be more. So, that is more likely. I hope you understood the concept of equally likely, less likely and more likely, children. Now, let us try to understand the terms random experiment and outcomes, children. So, here what do you notice on your screen, children? Yes, here 2 boys are tossing a coin. So, this you might have done many a times, right, children? Maybe when you are playing cricket match or some other games, generally you do toss a coin, right. So, what are the outcomes you are going to get? Yes, you may get a head or you may get a tail. These are only 2 possible outcomes, isn't it, children? Whenever you toss a coin, you just get either a head or a tail. Now, let us take another example of, yes, what is that shown on your screen, children? That is right, rolling a dice. Now, rolling a dice, now generally where you come across this? You may be coming across while playing Ludo or snake and ladder, etc. You might have played all these things, right, children? So, in rolling a dice, so how many outcomes will be there? Yes, you are right, there will be 6 outcomes, that is 1, 2, 3, 4, 5 and 6. So, even though you know the outcomes, children, but can you tell exactly which outcome you are going to get? Like suppose if you are going to toss a coin, can you tell exactly that head is going to come? No. If you are going to roll a dice, can you tell you are going to get exactly 4 on the top of the top? No, not possible, isn't it, children? Okay. So, the chance of getting outcomes is same and we cannot say what we would get. Such an experiment is known as a random experiment. So, you are tossing a coin is an experiment, rolling a dice is also an experiment. So, now let us see what actually you mean by a fair and unbiased, children. This is very important. So, here if we have seen already tossing a coin as well as rolling a dice. So, whenever we toss a coin or roll a dice, we assume that the coin and the dice are fair and unbiased. Now, what do you mean by this fair and unbiased, children? That means for each toss or maybe for a roll, the chance of all possibilities is equal. That means the possibility of getting head is same and the possibility of getting tail is also same. Similarly, on rolling a dice also, the possibility of getting any one, that is 1, 2, 3, 4, 5 or 6, all will be equal. Then only we say it is a fair and unbiased. So, generally in our topic today, in this entire probability chapter, whenever I mean to say a a coin is tossed or a dice is rolled, it means a fair and unbiased only, children, unless and until it is mentioned. Got it, children? Now, next we are going to learn about equally likely outcomes. So, a coin is tossed several times and the result is noted in a tabular form as shown on your screen, children. So, number of tosses, number of heads and number of tails. So, first we have tossed 20 times and I got say 12 heads and 8 tails, and when the number of tosses increased to 40, we got 25 heads and 15 tails. Then further it is increased to 60, then I got 33 heads and 27 tails. Then when 80 times it is tossed, I got 41 heads and 39 tails, and finally, when 100 times it is tossed, I got 51 heads and 49 tails. So, children, from this tabular form, what do you understand? Yes, you are absolutely right. As the number of tosses increases, the number of heads and the number of tails come closer to each other, isn't it, children? if you notice here, see, as the number of toss are increasing, right, here the number of heads are increased and number of tails also increased, but if you notice they are very closer, right. So, probably if you toss 200 times, you may get 100 here and 100 here also. So, as the number of tosses increases, so both will come closer and closer to each other. So, children, we have seen for experimenting tossing a coin, right, we have tossed for 100 times and we have seen. Now, let us roll a dice also and see what we are going to get. So, a dice is rolled several times, again the result is noted as shown on your screen. So, number of times we are rolling the dice, and these are all what, children? Yes, they are outcomes. How many outcomes are there? Yes, we are going to get 6 outcomes. So, when it is rolled 50 times, say I got 1 on top as 9 times, 2 as 5 times, 3 12 times, 4 9 times, 5 8 times and 6 7 times. Now, when the number of dice rolled increases to 100, then I got 1 as 17 times, 2 as 19, 3 as 19, 4 as 16, 5 as 13 and 6 as 16. Similarly, when it is increased to 150, say 200 and finally to 250 also, you can see these are all the number of times all these numbers, what do you call these are outcomes, isn't it, children? So, these outcomes has come. So, again if you notice in the last column, okay, last row. So, here 250 times, then you can see almost all are equal, right, children. So, in this case also what do you notice, children? So, rolling a dice for a larger number of times, the each of 6 outcomes. So, here there are 6 outcomes, right, children. They become almost equal to each other. Now, let us summarize this, children. So, we have seen on tossing a coin and also rolling a dice. In both these cases, we have seen that the different outcomes of the experiments are equally likely. So, tossing a coin are equally likely and also even rolling a dice is also equally likely. But why they are equally likely, children? Because there are certain experiments whose outcomes have equal chances of occurring, and such outcomes of these experiments are known as equally likely outcomes, just as tossing a coin or rolling a dice. In these two cases, yes, there is equal chance of getting each and every outcome. So, that is why we call it as equally likely outcomes. Got it, children? Presenter. So, children, till now we have seen what is random experiment, right, children, and also we have learned some terms related to probability. So, next we are going to learn about trials and events. Let us see, children. So, what do you notice on your screen, children? Yes, we have seen a coin is tossed and a die is rolled. So, each toss of a coin or each roll of a dice is called a trial, or it is also called as a random experiment. Got it, children? And also, how many possible outcomes are there to get a number more than 5 on the top face, children? Let us see. So, there is only one, right, children, more than 5. So, we have only one number, that is 6. That means, there is only one outcome, that is 6, which is going to come when we roll a dice. So, how many possible outcomes are there to get an even number on the top face, children, when you roll a dice? So, we have 3, right, children, because 2, 4 and 6, all these 3 are even numbers. That means, there are 3 outcomes, they are 2, 4 and 6. So, children, each specific outcome or the collection of specific outcomes make an event. Got it, children? So, here what actually outcomes are and what an event is. So, here there are 3 outcomes, that is getting an even number is an event here, okay, or getting a number more than 5 is an event here. Got it, children? So, let us see the examples here. So, getting a number more than 5 and getting an even number on the top face are 2 events. So, every outcome of a random experiment is an event. Got it, children? Now, let us link the chance to probability. So, tossing a coin, or what are the outcomes that we are going to get, children? Yes, there are only 2 outcomes, that is either you get a head or you may get a tail, isn't it children? So, now what is the chance of getting a head children here? Now, let us see. So, let us see what are the total number of outcomes children we have? 2 outcomes, right, that is head or a tail. Then what is the required outcome? I want a head, that means only 1, right. Now, chance of getting a head is 1 out of 2. So, there is one outcome which I need out of total outcomes. So, that would be 1 by 2. Now, this chance of getting we call it as probability of getting a head, and that is equal to 1 by 2. So, children, I represent P of h as 1 by 2. Now, 1 by 2 can be represented as 0.5. So, probability of getting head is 0.5 or 1 by 2. Now, let us convert this into percentage children, 5 by 10 into 100. So, we get 50%. So, the chance of getting a head or the probability of getting a head on tossing a coin is 50% or 0.5, or I can say 1 by 2. Now, let us see how to find the probability of getting a tail. So, again we have total outcomes as 2 only, but now my required outcome has become a tail. Again that is also only 1, right. So, chance of getting a tail is again 1 by 2, because one outcome I need out of 2. So, 1 by 2. So, that is nothing but the probability of getting a tail. So, which is half. So, again when you convert it into decimal or a percentage, you get 0.5 or 50%. Got it children? Now, let us see what actually we are going to get on adding these probability, that is sum of the probabilities of all the outcomes. So, here what are the 2 outcomes children? Yes, that is head or a tail. So, probability of getting head plus probability of getting tail, that is half plus half, that is 2 by 2, you get 1. That means, I can write probability of getting head plus the probability of getting tail is 1. Now, is it same for rolling a dice also? Let us check children. So, what are the outcomes here? Yes, there are 6 outcomes. So, you may get 1, 2, 3, 4, 5 or a 6. Now, there are 6 equally likely outcomes I can say, isn't it children? Yes. Now, what is the probability of getting each number on the top? So, I want to get a 1 on the top, that means 1 out of 6 outcomes. So, its probability of getting 1 is 1 by 6, or I can write P of 1 is 1 by 6. Then what is probability of getting 2 children? Even that is also 1 by 6. Likewise, probability of getting 3 is 1 by 6, probability of getting 4 is 1 by 6, probability of getting 5 is 1 by 6, and also probability of 6 is also 1 by 6. So, that is why we call them as equally likely outcomes children, because see, chance of getting all the outcomes is equal, isn't it children? Now, let us find some of probabilities of all these outcomes children, that is P of 1 plus P of 2 plus so on up to P of 6, that is 1 by 6 plus 1 by 6 plus so on up to 6 times, and adding them, what do you get children? Absolutely right, that is 1. That means, P of 1 plus P of 2 plus so on up to P of 6 is equal to 1. Let us summarize this now. So, sum of probabilities of all the outcomes when we toss a coin, that is probability of head plus probability of tail is 1. Again when you throw a dice, sum of all the probabilities, sum of probabilities of all the outcomes, that is probability of getting 1 plus probability of getting 2 so on up to probability of getting 6 is 1. Hence, I can say sum of the probabilities of all the outcomes of a random experiment is always 1. Okay, children. Now, let us see what is the probability of getting an odd number on the top face children. So, we have seen already total number of outcomes are 6 and required outcomes are 3, that is 1 or 3 or 5, because odd number is 1, 3 and 5 out of 6 outcomes. So, probability of getting odd number is 3 by 6, that means I can write it as 1 by 2. Now, here this A actually represents an event, just now we have seen also probability of getting head. So, getting head is an event, okay children, here we denote it as A. So, now let us define what probability is. Now, probability is a branch of mathematics which deals with numerical descriptions of how likely an event is to occur. So, the formula for probability of an event A is given by P of A is equal to number of favorable outcomes per event A divided by the number of total possible outcomes. So, children, now let us look at the image shown on your screen. So, what actually is shown here? We are going to toss 2 identical coins at a time. Now, in such case, what are the total number of outcomes, children, or what are the possible outcomes you are going to get? We have already seen when one coin is tossed, we get only two outcomes, that is head or a tail. But when you toss two at a time, how many possible outcomes will be there? So, let us see first coin as well as second coin. So, you may get both heads, that is head in first coin and head in second coin also, or you may get head in first coin and tails in the second coin. Then third one, you may get tails in first coin and heads in the second coin, and finally, you get tails in both the coins. That means, total how many possible outcomes are there, children? Yes, there are 4 possible outcomes. Now, what are there? Both heads, first head, second tails, or first tails, second heads, and the last one is both can be tails also, children. I hope you understood how to find the possible outcomes, children. Got it? Yes. Now, let us see probability of an impossible event. So, what is the probability of getting 0 on rolling a dice? Total number of outcomes, you have seen it as 6, children, and what is my favorable outcome, children, here? 0. But when a die is rolled, do you get 0, children? No, you get either 1 or 2 or 3 or 4 or 5 or 6, but you will never get 0. That means, probability of getting 0 is equal to number of favorable outcomes per event, that is getting 0 divided by the total possible outcomes, that is 0 by 6. So, 0 by any number is 0, hence the probability of an impossible event is always 0. I hope you understood this point, children. It is very important to note. Now, let us see probability of a certain event. So, let us take an example, children. What is the probability of getting a number less than or equal to 6 on rolling a dice? So, total outcomes are 6, and how many number of favorable outcomes are there, children, for you? Yes, 6, because all the outcomes, that is 1, 2, 3, 4, 5, 6, they are all less than or equal to 6. So, that means, my favorable outcomes are 6. So, again substituting in the formula of probability. So, on substituting the values, I get P of A is 6 by 6. So, on simplification, you get it as 1. That means, we can say that probability of a certain event is always 1. So, let us note a few important points, children, that we have already learnt. That is, sum of the probabilities of all the outcomes of a random experiment is always 1, and probability of an impossible event is always 0, whereas probability of a certain event is always 1, and finally, the probability of an event always lies between 0 and 1, and both 0 and 1 are included in this, children, because 0 is for impossible event and 1 is for certain event or sure event, I can say. So, let us see the use of probability in real life, children. So, you might have seen meteorological department predicting the weather forecast, right, children. So, every day you might have seen maybe in television or somewhere, right, they will be showing some images as you can see, right. So, these all are predicted from the data they observe for many years. Okay. So, previously they will collect the information all those years and they predict using probability, the weather forecast. Okay, children. And the next one is in insurance companies. So, insurance companies calculate the probability of happening of an accident or casualty to determine insurance premiums. So, every month or maybe every year you need to pay some insurance premiums, right, children. So, this is calculated based on probability only, children. Okay. So, that is also one application of probability in real life. And then the another most important one, that is about exit polls. So, you might have heard about this exit poll, isn't it, children? So, generally the exit poll is always taken after the election. So, what actually they will do here? They will survey the people and they will ask them to which party they have voted, and based on the information collected, they will predict or they will tell who is going to win in the election. That is how they make the predictions. So, this is again purely based on probability only, children. So, children, till now we have learnt about some basic concepts in probability chapter, and also we have defined what a probability is, and also we have learned some of the uses of this probability in our daily life. Now, before we conclude, let us quickly recap what we have learned in this session, children. So, an experiment is an action or process that results in well defined outcomes. There are certain experiments whose outcomes have equal chances of occurring, and outcomes of such experiments are known as equally likely outcomes. A trial is an action which results in one or several outcomes. An event for an experiment can be defined as the collection of some outcomes of the experiment, and probability of getting an event A is equal to number of favorable outcomes of event A divided by number of total possible outcomes. The probability of an event which is certain is 1. The probability of an event which is impossible is 0. Then the probability of an event always lies between 0 and 1. And finally, sum of probabilities of all the outcomes of a random experiment is always 1. So, children, before we conclude, I would like to give you some homework to do it and show to your math teacher. So, let us see the first problem, children. Give examples for each of the following that you come across in your daily life, that is certain events, impossible events, and equally likely outcomes. Now, what are the uses of probability in real life? The third question is, if 3 coins are tossed simultaneously, then what are the outcomes, and also find the number of outcomes. And the final question is, if 2 dice are rolled simultaneously, then what are the outcomes, and also find the number of outcomes. So, children, with this we have come to the end of our mathematics digital class of probability part 1. So, we will meet in our next mathematics digital class. Until then, goodbye, take care and happy learning.